Welcome back to our next concept, 1.2, add and subtract signed numbers. And for our first example, Rosa represents her school as -2 because it is 2 blocks south of her house. Yesterday, Rosa left school and walked either north or south to a friend's house. If she walked 4 blocks, which values could represent where she ended up? So first, we draw a number line. To the left are negative numbers and to the right are positive numbers. We also know that to the left, Rosa represents south, and to the right, she represents north. She starts by placing her house at the number 0. She also tells us that she places her school at -2 because it is 2 blocks south of her house. So, if she walks 4 blocks, she could either walk to the left, which would be -6, or to the right, to the north, which would be 2. So the two numbers that represents where she ended up would be -6 and +2. For our next example, a football team recorded the following sequence of plays. On the first play, they gained 8 yards. On the second play, they lost 3 yards. On the third play, they gained 12 yards. On the fourth play, they lost 5 yards. Where did they end up relative to their initial starting position? We can represent it by numbers. So if in the first play they gained 8 yards, it's +8. On the second play, they lost 3 yards, -3. On the third play, they gained 12 yards, +12. And on the fourth play, they lost 5 yards, -5. All we have to do is do +8 minus 3 equals 5, plus 12 equals 17, minus 5 equals 12. And our next example. One January morning, Sophie wakes up and goes outside to check the thermometer. The temperature is -3 degrees Fahrenheit. The next time she checks, the temperature has risen by 6 degrees Fahrenheit. By late morning, a storm is approaching, and the temperature changes by -4 degrees Fahrenheit. After the storm blows through, the temperature rises by 2 degrees Fahrenheit. When Sophie checks the thermometer one last time, the temperature has changed by -6 degrees Fahrenheit. What temperature does she read at her final check? So again, we just write down the numbers. We start by a temperature of -3 degrees Fahrenheit, which would just be -3. Then it rises by 6 plus 6. Then it changes again, -4 degrees Fahrenheit, -4. And then it rises again, +2. And finally, it changes by -6. We can just represent by -6. If we do all that addition, -3 plus 6 is 3, -4 is -1, +2 is +1, and finally -6 would end up to be -5 degrees Fahrenheit as a final check. What is the sum of these numbers? That would be -2, 6, -4, 9, -7, 2, -1, 5, -3, and 5. And again, we can just write them down and do the math from left to right. -2 plus 6 minus 4 plus 9 minus 7 plus 2 minus 1 plus 5 minus 3 plus 5. We can also draw a number line to represent this addition problem. First, we're at -2, so from 0 we move to -2. From -2 we add 6, so we move to the right, which would be 4. From there, -4, we move to the left, end up at 0, plus 9, from 0 to plus 9 is 9. Then -7, from 9 minus 7 is 2. Then we add 2, which we end up at 4, subtract 1 is 3, plus 5, which would equal 8, minus 3, which we end up at 5 again, and then we move 5 places to the right one final time, which would be 10. For our next example, find the value of the expression parentheses minus 3 plus 2 minus 12 minus parentheses 6 plus 11 minus parentheses 4 minus 15. So the first thing we have to do is figure out the problems in the parentheses. So in the first one, negative 3 plus 2 would be negative 1. Then we have minus 12 minus another parenthesis, so we have to do that parenthesis. 6 plus 11 equals 17. Minus another parenthesis, which is 4 minus 15, and 4 minus 15 equals negative 11. After that, we can just simplify. We take away the parentheses, and it's minus 1, minus 12, minus 17, minus 11. We can further simplify because we have a double minus sign. So minus 1, minus 12, minus 17, and then above that we had minus 11, and we remember that minus becomes plus. So it would be minus 1, minus 12, minus 17, plus 11. So we can also just continue with the negative numbers first. Minus 1 minus 12 equals minus 13, minus 17 equals minus 30. And we leave the addition at the end, minus 30 plus 11. Now we do the final addition, and we do minus 30 plus 11 equals minus 19, or negative 19. We move on to our next example. Scientists sometimes look for changes in temperature to determine the strength of a chemical reaction. Consider the data for sample A as shown below. So we have our thermometer information in this graph. How would you represent the change in temperature of the following sample? So first, we have to figure out where those changes are. We only have numbers to the left, which are negative 40 at the bottom, negative 30 in the middle, and negative 20 at the top. But that is not where our temperature reads. So we need to figure out where exactly that number is. So exactly at that line, which is between negative 30 and negative 25, we can figure out that between negative 20 and the number negative 30, at the exact middle, is negative 25. We move on to the next one, and that one is a little bit below the middle of negative 30 and negative 4. All we have to do is understand those lines and count either up or down, from negative 30 down to negative 40, which would be negative 31, negative 32, negative 33, negative 34, negative 35 in the middle, and one less, which is negative 36. Another way we can represent this change would be negative 25 from our first thermometer plus what number equals negative 36. So to understand what that mystery number is, we can just add on the left plus 25 minus 25 plus 25, which is equals 0. So that leaves our mystery number alone. And if we did it to the left, we now must do it to the right. Minus 36 plus 25. So the mystery number ends up being minus 11, or negative 11. So from negative 25, we move down, or negative 11, to reach our final temperature. For our next example, the Great Pyramid of Giza in Egypt was completed in the year 2540 BCE. In 1969 CE, the first astronauts landed safely on the moon. If you took a time machine in 2015 CE and went back 2,500 years, which event would you be closer to witnessing? Now, this can also be represented in a number line because there's a lot of numbers here, a lot of large numbers. So the first information we have is that at the year 2540 BCE, the Great Pyramid of Giza was completed. So we can represent that at the bottom as minus 2540. We also are given that in 1969, the first astronauts landed safely on the moon. So that is positive 1969. We're also told that we're in the year 2015 CE, and we're going to go back 2,500 years. So we represent moving back by moving from 2015 to the left 2,500 years. We can represent this by saying 2015 simply minus 2,500 years, which equals minus 485. Finally, we have to figure out the distance between the Great Pyramid of Giza being completed and the first astronaut landing safely on the moon. On the first line, we have to go from negative 2,540 to the year negative 485, and from the year negative 485 to 1969. So the way you figure out the first one of the Great Pyramid of Giza is negative 2,540 plus a mystery number equals negative 485. To eliminate the number to the left, we just simply add that number. Negative 2,540 plus 2,540 equals 0, and negative 485 plus 2,540 is simply 2,055 as our mystery number. And to the right, we have, again, the year negative 485, which we took our time machine to arrive, plus a mystery number equals 1969. So to eliminate those numbers, we simply have negative 485 plus 485, so that equals 0, and our mystery number would be 1969 plus 485, which equals 2,540. Now, what event would we be closer to witnessing? So we simply choose the smallest number, which is the closest number to us. And in this case, it would be the Great Pyramid of Giza being completed. Our next example, choose the correct sign to make a true mathematical statement of the following. So we have parentheses, negative 11 plus 3, and we have a mystery sign for parentheses, negative 9 minus another parentheses, minus 2. So again, we just need to complete the parentheses first. So negative 11 plus 3 is negative 8. We have a mystery sign in the middle, and we figure out the next parentheses. We have parentheses minus and minus number, which again we represent by positive, so it would be minus 9. Minus minus 2 becomes plus 2. Minus 9 plus 2. And we can further on simplify. Again, we remove the parentheses. Minus 8 just stays as minus 8. And we have another parentheses with an addition problem. Minus 9 plus 2, which simply becomes minus 7. The correct sign would be minus 8 is less than minus 7. And we know this because, simply put, minus 7 is closer to the number 0. And that is why it is greater. Next, which expressions are equivalent to 14 minus 20? So first of all, we can just flip those numbers and put minus 20 first and 14x, which would be minus 20 plus 14. Next, we can still continue putting minus 20 first, and another way of just simple addition would be by two minus signs. So we can put it as minus 20 minus parentheses negative 14, which also makes plus 14. Then we can continue putting 14 first, and we can add in parentheses negative 20. We remember that plus and minus eliminates the plus, and it just stays 14 minus 20. But it would also be the correct expression. Next, which expressions have a value equal to the following expression? So the expression would be minus or negative 2/3 minus parentheses negative 5/6. So again, we can simplify. Negative 2/3 stays the same. Minus and minus becomes plus, so negative 2/3 plus 5/6. We can continue developing this expression by saying that the equivalent fraction of minus 2/3 or negative 2/3 can be multiplied by 2, so it would become negative 4/6. 2 times 2 is 4, and 3 times 2 is 6. That would be an equivalent fraction, 2/3 and 4/6. That way, we can actually complete this expression of negative 4/6 plus 5/6, which would equal 1/6. And we can simply say that we can just do the top, negative 4 plus 5, which equals 1, and the bottom stays the same, 6. 1/6, or 1/6. And finally, we have our last example. Lana and Emily are playing a competitive word game. Whoever plays all of the tiles first gets to add the value of their word plus the total value of all their opponent's remaining tiles to their score. Also, the opponent must subtract the total value of all of their tiles from their score. Suppose that the current score is Lana, 324, Emily, 358. If Lana's last word is worth 7 points, how many points does she need Emily to have in her hand in order to win? Well, this is a very complex game. I think we're just going to skip it. But teacher, I want to know the answer. Students, I think this is too complex. We can just skip it if you want. I don't think the teacher knows how to do it. I do know how to do it. I just don't want to. But it is a math class. I think maybe we should just go on and do it. All right, let's start. First, we know that Lana ended up with 324 points, and her last word is 7 points. So we can easily figure out that with the rules, we can add those points to her score. 324 plus 7 equals 331. Then, by the rules of the game, we know that she gets to add to her score 331 plus the last cards that Emily has. Then we can figure out, we can add her score of 331 plus the number of cards that Emily has. So it's 331 plus whatever Emily has. We also know that Emily, who has 358 points, must subtract her points in her last hand to her result, which is 358 minus Emily's cards. She also subtracts her opponent's total value from their score. So whatever Emily has, which is 331 plus Emily's points, would be minus 331 plus Emily's points. We can represent that by saying minus 331 minus Emily's point using the distributive property. So if we have minus parentheses 331 plus Emily, we can put the minus in front of the parentheses to the 331, which is minus 331, and minus plus Emily would just be minus Emily. 358 minus 331 equals 27. Minus Emily equals minus 2 Emily. So we represent minus 27 minus 2 Emily, which in this case we just put it by the word E. So minus 27 minus 2E, which is 2 Emily, equals 0. To represent what number we have to eliminate from the left side the number 27. So we do plus 27 minus 27 plus 27 is just 0. And 0 plus 27 is 27. We end up with minus 2E, which remember is 2 Emily, minus 2 Emily equals 27. Now, we need Lana to win. We need to figure out how much she wins, not equal to Emily. So if we don't want her to equal Emily, we want her to beat Emily, she needs to have at least 1 point more. At least 1 point more. So from negative 2E equals 27, we can just add 1 more point, which would end up being 28. From that, we can then see what Emily has by just removing the 2, which is 2 times Emily. We can divide by 2, and we have to divide by 2 on both sides. That would be Emily alone equals 28, remember 27 plus 1 more point so that she can win, divided by that number 2. 28 divided by 2 equals 14. She has to have at least 14 points in her last hand in order for Lana to win. See, I told you it was hard, but that is how you get the answer. Now, I don't understand why this was the last example in this concept. It seems very hard, and I'll make you a deal. You should raise your hand right now. Go on, raise your hand, and tell your teacher, the new teacher, our robot teacher, Slybot, is asking you to please not put this question in a quiz or an exam. This is too hard. Go on, raise your hand, tell your teacher. Are you doing it? Did he see you? Is he coming over? All right, now tell him. Tell him to please not put this question on a quiz. It's too hard. The robot says so. Okay, I think he agrees. All right, so hopefully this question won't be on a quiz. Or maybe it will. I don't know. I don't know your teacher. Concept 1.2, add and subtract sign numbers. Bye-bye. Self-destruct in 10.
Please push the red button. Yeah, the red button. Just push it. Yeah, the red button. Push the red button. Okay, come on. The red button. Push it. You're gonna let it self-destruct? If you subscribe, you're forgiven for trying to destroy the world.